Yo, yo, what's up, everybody? Haha, it's Papa Bale. Welcome to the channel. I'm glad that didn't happen. Awesome. Hello, hello. Hey, hey, what's up? Papa Bale, how's it going? Just testing out different coil configurations here. I got a parallel circuit going right now. See here, 4.5 volts, 0.5 amps. But it's hooked up kind of nice. Let me show you real quick. All right, so what I did is I got this littler, smaller coil as the main drive now. It's got about it's a lot smaller than this one. I moved this one to be a secondary, and it's connected to this little one. So these two coils are on this transistor right here. See, you can barely see it. There's two there, but there is two transistors here, one here, one here. So it's hooked up kind of more intricately than it needs to be, I would say, but it's kind of interesting how it functions. I got this coil and this coil are adhesed to the table. I glued these two down, move the trigger coil and the big pickup coil around. All right, but let's do a test. We'll remove coils as we go. Do you want it to be it's going to be a timed test. You can either do 30 seconds or a minute of acceleration time. At 4.5 volts. Well, 4.44. All right. 55, 56, 57, 60. Divide by 3, and that's how much that one. With all 3 coils going, that's how much it is. At this rate here. I figured that as long as we're going to do the tests, we should have them be timed, at least to around to the second, in comparison to the other tests. No, the time should be a constant. All right, so we don't need to really take any of this apart. What we need to do, unground this, and there. Now, I don't know. See that the power is still going to it, so I'll unhook that too. Power. Now we've removed these 2 coils. And we're just working with the main drive, which is this little one right here. We'll do another minute test. .45. Wow, okay. 11, 6, 7, 9. All right, I don't think we got momentum on that one. I'm going to stop it and start it again. Reboot. Need to make sure all this is connected properly now. All right, maybe there needs to be more momentum to get it going, which would make it an illegitimate, it's not a good test to do if that's the case. Because if it can't start like at the same way, then it's totally null and void. Boom, doesn't even apply. Whew. And obviously placement is a little bit more important. Well, maybe not the placement, but the actual initial startup speed is more important here. Because it looks like I could move it back to where it was. Yeah. All right. Anyway, this is 4.5 volts at 0.5.6 amps. It's still going up, so 0.6, we'll call it. And that is 2.5 watts, pretty much, maybe a little less. We'll just show you that for, it's about the same. Okay, now we're going to hook up the other two and disconnect the main drive. Oh man, it's so like relaxing and at the same time. I think you relax so well because your heart's beating so fast. Hmm, makes sense to me. Now, power plug. Disconnect the ground. I think if we just disconnect the ground, that whole thing will cease to function. But I don't want to like burn the transistor if that's at all possible. I don't think it's even going to be possible. Let's try it. Turn it on. Boom. That's definitely picking up speed. It's going really slow. Hmm. Oh, that is definitely not working. Sure, everything's lined up. Hmm. Hmm. Awesome. All right, so what are we going to do now that that isn't working on its own? I never tried it by itself, so that's obviously what's going on there. I'm not hooking it up right or something. Linear coil, coil to ground, powered collector, base, trigger coil. Everything looks good to me. So instead of breaking it up like we've been doing, why don't I just hook it all together? Did I already have that done? Just hook them together one at a time then. Find out like where the problem is. All the way off. All right, so that's in there. Here. Extra connectors now. All right, I need to get diode. I know I got one line around. Here we go. You use the bigger diodes when you use these connectors. Was it going to be long enough though? Now these two coils are connected with a DC rectifier diode. And then there's lots of diodes connecting this coil to itself, so that's awesome. Yeah, let's see now what's going on with this before we disconnect that situation over there. Just want to see if this is. Oh. Hey, you see that just popped right out of there? That's not that safe. Yeah, if we just get it on there, it shouldn't be too much of a problem. All right. Power. Voltage. A little bit more voltage. You can hear it's working. Still not pulling any amps though. It's not 100 milliamps yet. Here we go, 100 milliamps. 7.5 volts. That would have taken forever at 4. Just would have taken too long. So cool. I mean, when it works, it's cool. When it doesn't work, I kind of, I get frustrated. Then I'm like, calm down. We're gonna figure out where the hole is, where the connector isn't connected right. 'Cause nothing's on fire. You obviously hooked it up right. Just might not be tight enough. But we're gonna remove. Wow, 12.5 volts. We're gonna take this coil out of play. Wow, it's great, great. What you call it? Efficiency is better than it is without the 3 coils in there. 3 coils lower the amp draw. Less amps needed to make it run. Not sure exactly what the ratio between the speed and voltage and ampage is, but each decibel here has its own sound, its own frequency on the motor. So like 12.6 volts and 0.3 amps sounds different than 12.7 volts at 0.3 amps. Totally different. I don't know why it's like that sensitive, but it's like they're different. And I can imagine trying to drop a needle on that thing. Yay! Hmm. So these are all 20 gauge wire. This is how I made it. I did 16 feet, about 5 laps. That's there and back 5 times of 16 feet. And then I twisted it up with a drill and I cut the loops that the hooks, the head of the apparatus. I cut it to make it 10 strands. So it was 5 laps. It's going to be 10 strands when you cut the loops. Then I tied all those together in a series circuit with some rectifier diodes. I put 3 diodes in the coil. So not every wire is connected by diode, but like 3 of 10 are definitely connected by diode, which would make it a series circuit of like 3 wires, diode, 3 wires, diode, 4 wires, ground. That's how the coil works. I don't know, there it goes. Yeah, I don't know, a lot of stuff, but that's not the point. Look here. These coils only have 6 strands, I think. 4, 8, maybe 8 strands. The 2 little ones were 16 feet, but then when I got done wrapping 10 feet of it, or maybe 12 feet of it, it had filled the bobbin completely and it was spilling over the edge. So I just cut it, made another end, and then made this little 6-foot one over here. So, and these are, let's see here, 1, 2, 3, 4, 5, 6. 6 connections. That's yeah, I think that's like there and back 4 times. But I didn't do a full 4 times. It was there and back and there 1/2 time. I just used all the wire that was left on the spool to make these 2 coils. So, you know, I think that's pretty awesome. Hey, what's up, man? DJ Bale, what's up? Peter, what's going on, bro? How you been? All right. Cool, man. That's good. My 3D printer, oh, they're all broken now. So I actually did the dumbass thing and bought another one. They're really stupid, man. Totally on credit. But you know, I feel like I got to keep moving on this. I feel like I don't have much time, really. Strange if you think about it. Hmm. Yeah, so I mean, they all work on a single series circuit and they work pretty well. I had them working on the parallel circuit, but I don't know what happened there. I know it's not the transistors because they're cold and I just put that one in there from the box. Oh, it's good. It was just working, so I know it's all good. Just probably bumped. These wires are long and stiff, so bump into one, they're liable to come disconnected. I'm pretty sure. Wow, that is not good. So much of an acceleration phase. It wasn't working like that a second ago. But I was just using this little coil here a second ago. All three. Hmm. So I don't do this very often. We're going to turn it up. That's smooth. It goes up to 20 volts. Didn't even reach full amp though. Really good. Really good efficiency and power cost. We'll do that again, except next time I'll have my tack meter like in my pocket. So we'll see how fast that was. I think it was right around 2,300 RPM. Good, good. How we doing? The world? Man, I'm only worried. Oh no, that's not good. Oh, because man, I got something happen. I got some kind of food poisoning or something, and if it just like keeps getting worse. But you know, I've gotten used to it. So, but I know it's there. I feel it like no matter what I do, it's like it's latched onto my body. Weird. Oh, I mean, I was really sick, man. It felt like a tremendous anxiety attack that just wouldn't go away, and it like spread. But there was no reason for me to be afraid. You know, it wasn't. It was weird. It was just strange, and it wasn't like. It just felt like that. My stomach felt like that, but then it felt like I got poisoned. You know, my shoulders were all. You know, all my muscles felt like they were seething. Whatever it was, it just sucked. And I went into the ER twice, and they said I did not have a virus or a flu or anything like that. They said drink lots of water, and so that's what I've been doing. It's, my work is very rudimentary. It's very basic. In my mind, it's like I like just staying on this level because I just have a feeling stuff is going to work more on this level than it's going to work on other levels. Wow, that is so slow. All right, we're gonna deal with the slowness. We're gonna take care of this. Because with the one coil, when I say the one coil, I'm talking about this one right here. With this coil, I had it on 4.5 volts. It was all the way up to 1.1 amps, and it was moving like a freaking freight train. We'll take a fresh one. I voted today. I have to vote a certain way because of my. I mean, if we made certain things nonpartisan and that both parties have to participate in, this world would be a better place. But the freedom of choice in this regard sets us back eons. It's not really two ways to look at this, because the front of the coin is my face and the back of the coin is my ass, and you are looking at me, and that's it. There's no two sides here. really. What I'm talking about is how you have to address certain things like veterans. Okay, veterans should be handled the same way on both sides of the fence, or how many freaking sides of the fence there is. It doesn't matter. That's not what we're arguing about here. We're arguing about, like, I'll throw it out there, mental illness shouldn't be a freaking option as to whether or not you are going to handle mental illness or not. Shouldn't be a fucking option. You either do or get lost because you're useless. Right? And every time, man, I worry about my situation. Not very much though. I think that everybody's kind of coming together on it, that, it is an issue, a real issue that needs to be addressed, by and scrutinized. And it all has to be looked at really, really closely by both sides. And yeah, you're allowed to view it and what can be used to treat things in different ways. That's fine, but you can't tie your money up with what you've chosen. Okay, you have to put forth your funds every time. You can think whatever you want, but your money has to go where it needs to go. You know what I'm saying? You can't just prop people up and then knock their fucking stilts out from under them and then laugh. Yeah, watch how many times you get to do that. All right. What is this? What is this? I'm a strong advocate for, mental illness rights. I am 100% for the government taking care of people that really, they do their best, but honestly, when it boils down to it, they need help, and you have to help them. Shouldn't be an issue. Shouldn't be a partisan issue at all. No, nobody would want to do this just to get the government to support them, because living like this sucks. Okay, it sucks. There's nothing cool about it, but it keeps you going, man. Keeps you going, but you got to keep. And I've tried to get out, not like I thought I was a normal. I tried to get out of there, man. I'm like, okay, we're gonna go live our life. We're gonna be cool. And right at the exact same time, my grandma died. And guess what? She left us money, a little bit of money. There was just enough money to. Oh man, I'm glad I made the purchases I made, honestly, because they're long-term investments. But I'm still worried about those too, because things change all the time, man. Things are changing. I watch things change. I know they change, and I know they go back and forth and whatever, but I know they change. I'm sitting here arguing with myself. I haven't looked back at the monitor. I'm like, okay, but yeah, if that's the case, then what about this? And I'm like, well, yeah, that's a thing too, but there we go. There's the one coil, 4.5 volts. And I mean, sure, you can say, yeah, he thinks he's hot shit. And that's all that's going on here. He thinks he's the king ding, and he just strutting around like that. But it's way more like deep, man. It's all kinds of, you don't have any idea, summing it up like that, what's going on here. It's like, God, read a book. You want to know about it, read a book about it. And I honestly, I have admitted that I don't read much. Been reading a little bit more recently, but I'm out of practice, man. It hurts my head to fucking read. I really don't learn anything from reading. Looking at pictures, I learn more from looking at pictures than I do from reading words. And there's a lot of words out there that I'm like, oh yeah, really? Show me the scat. Show me the petrified dung. Show me something. Don't ask me to just say, wow, hell yeah. Don't ask me to do that, man, because it's like, and I get it. I totally freaking get it, man. But I see so much that is to the contrary, okay? Even inside, so there's so much that is not adding up. And what am I talking about? I'm talking about books. I'm talking about the written word. I'm talking about reading between the lines where there are no words and finding out what's really going on. Because honestly, I believe that everything that comes out of our mouths is not intentionally, but inherently a lie. We don't know what we're talking about. None of us. That's why I talk a lot, and I know that what I say is very opinionated sometimes. So this is just the one coil right here. 4.5 volts, 5 amps. Just this one. That's so cool. That is so cool. Because it's so tiny. I mean, Jesus, you saw how fast this thing was moving at not even 5 volts, man. It is so freaking cool. So yeah, man. I mean, the minute you have it all figured out, I don't even know, man. I will never have it all figured out. I know that for a fact now because everything is moving and everything is changing. The minute you have something figured out over here, and then you figure this out over here, this has changed to something else. And it's totally different. So what I'm saying is your entire thought process, pretty much, and this is where the written word is cool, and I appreciate the written word, is confined to your reach or your radius. You only know what's going on in here, except for, the written word. Somebody could write down what's going on over here, and you could read about it, and, and of course, it's common sense. I'm just trying to get out that I take great displeasure in reading. And I know that is like a sin or something, but the only book I read from cover to cover was 60 pages long, called Somewhere in Time. It's about two soulmates that never really hook up, and they both die on the same night in different scenarios, trying to meet each other. So yeah, that was a tearjerker, man. I was like 13 years old, and I read it, and I was like, ah. I read Sir Arthur Conan Doyle's Sherlock Holmes. That was a nice thick book. I read that one. This is so neat, though. I mean, I found quite literally that there are many, many reasons why the twisting of the wire works better than your standard straight wrap like that. And I might undo these ones, actually. Since they're 20 gauge, they might come undone pretty well. I'm going to make another counter rotator, another counter rotating pulse motor with the twisted wire this time. And there's going to be little coils. I'm going to print out, and put the coils in there and have them spin instead of like trying to glue them on top, like somehow as fix them inside the rotor itself. Oh man, that's going to be nice. That's going to be so cool. Yeah, so I don't know exactly. Yeah, I could like dismantle this one and try to use the 20 gauge, but I don't. I think I'm gonna either have to get new 20 gauge or use the 26 gauge wire that I have. I don't know if I'm gonna be able to get the 20 gauge anytime soon, but yeah, I'm gonna make 3 of these ones this size, and I'm not sure. Like, I might have another one on the top with like 32 gauge coils in it, and I don't exactly know how I'm going to do that. I might have a case actually. So it would go, the bottom would go on here, the drive coils would go on the bottom part, and then you'd have you put this on. So you put that on, and then you put the top on with the coils, and then you can spin the outside, spin the coils like so, and then the rotor would spin the other way, but you wouldn't be able to see it unless I open it up with like windows so you can see in. That would be this rotor would be completely enclosed with the drive coils on the bottom, maybe some generator coils on top of some kind that would feed into another circuit. But yeah, it's all gravy. As soon as I get my printer working. Yeah. Choose your own adventure. Man, those stories were the bomb. Like, so cool. Of course, I read every page, so it was like I couldn't piece it together until I actually read it in the story format. But those books are fun. All right, so this coil, you see, that's super duper. That compared to what we were just looking at, that is so fast of a pickup. The speed's picking up a lot faster than it was before. All right, so now let's do this real quick. That one's a little bit shorter. I don't know if it's going to work. I'll have to switch it out if it's not going to work. Yeah, so everything that happened in the past is forgiven, and we are moving forward. I hope, anyway. I saw a bunch of stuff, but I didn't even look at it. I'm just have no idea really what happened. All right, so we got the little coil and then we got the big coil hooked up now. With that much more wire, that's 160 feet of 20 gauge all twisted up. Definitely a lower amp draw here. Wow, there's something on the bottom of this one. The magnet picked it up. Oh no, I missed that. Okay. Seeing this big coil has this 20 gauge all wound up, right? There's a 32 gauge wire that I put in there with it. But like sorting through that thing right now is not something I'm looking forward to doing. Because it's like 10 strands of 32 gauge, which is indeed very much harder for me to work with. Man, yeah, I've been sitting on my hands for like 3 or 4 days just waiting. And then I'm like, okay, I'm going to do this. And now I'm just waiting for that to come in the mail. So this is a very smoother, slower acceleration. We're at 12 volts, 13 volts, 0.5 amps. And then I believe that twisting the wire puts an antiphase into play. That does not occur in the straight wind. So I mean, there's lots of different things going on here with these coils that aren't typical because it's so small. It's literally only 160 feet of wire right there. Almost 2,000 RPMs right now. A little under. 2100. There it is. 20, 23, 23 and change. $22. My bad. All right, so then that's totally my fault. 2200 RPMs. Ooh, yeah. So exactly what I'm going to do is I'm going to print out an 8-inch disc like this with only 3 holes in it. I'm going to print 2 of them. It's going to be the same size as this one. And one's going to have 32 gauge coils and the other is going to have 20 gauge coils. All right. So here I was putting forth like a guessing game on my community page. Here's your two magnets right here. Of course, they're not going to work as well as the big ones because they're not as good. I mean, for this one anyway, for this particular motor, the cube magnets will not work as well. We have our 180-degree setup here. Let's give it a ring. See if we can even get it to go. Now the coils are not set up very efficiently for running this type of situation here. Yeah, like the 2, I think would be way better if the trigger coil was actually inside the coil, because then the positioning would be better. Huh. And I have yet to try a reed switch with the twisted coils. I'm kind of itching to do that. But maybe we'll leave it with these. All right, we're gonna take this apart as graciously as possible. What we need to do is get all right, and since there we go. Oh man, I hope that worked. I might have to strip it a little bit, make sure it works. I'm actually gonna do yeah, I'm not sure, man. That's so difficult to assess. You gotta kind of eyeball it unless you strip those. I might strip them. Mm. So I don't know, man. This is very weak in my opinion. I'm gonna get going real quick. Hmm. So like soothing, kinda, but oh, not really. It's hot where I'm at right now. It is very hot. Okay, so that's not so great. There's a strong resistance on this reed switch, though. Both sides of it. Make some sparks. All right. All right. I don't know. I think the resistors on the line here is what prevented that from functioning right. It's weird how like a trigger coil resistors will make it function better, but just off a reed switch shouldn't use resistors, I don't think. I mean, there's ways to hook them up, but I've never had any luck with them and having it run effectively the way I build it. None, like none. Except with the trigger coil, this one right here. It's the only time it's ever worked. Mm. So I'm gonna hook them all up again. It's because I think that's the best way to do it. There, and then this one goes in that slot. There we go. Let's see. Sure everything's all plugged in. So, I mean, yeah, this is it. We just went under 100 milliamps, 8 volts, we'll call it 8 volts. In between 0 and 100 milliamps. Nine volts. And I think there's more torque because you get up to your speed at a much more significant rate. So, I mean, it's still increasing in speed, but it's increasing at a very slow rate of speed. So, like, if I were to turn this off, turn this up to 15, and turn it on, yeah, it's going up about 100 per click. All right, so that's 5,000 divided by 3. So there's a lot less speed involved in the lower voltages with the 3 coils. So you got to turn. If you want to go faster, you have to turn up the voltage. You have to have your amperage open all the way. At least for my supply, you do. And then it'll add amps. And take them away as necessary. $2,000 RPMs. Just under 2,000, actually. You see, when I flip the switch, the ground is connected and it sounds so different. Turn it off. Turn it on. Turn it off. Turn it on. And the amount of voltage is 0 going in right now, but the ground, when you flip this switch, the ground gets cut to the power supply. And yeah, and if it needs to, the energy needs to go to ground, you have to leave that switch on. I mean, you can have it, turn it off, and then it's all in there, but you got to have that make sense for it to work any kind of way. And I haven't really tried that stuff yet, but this is an effective way to close your circuit. Well, open it. You know, what I'm trying to say is to unground your circuit, just flip the switch. Because, yeah, the frequency of when it's on and when it's off are different at higher speeds, like way different. Because actually, I believe there's a ground, when it's weird. Because, I mean, it's like effectively, if it's grounded, it's still working, kind of. There's no power being sent back into the circuit right now, so yeah, it's just you can do that. That's my point. If you need to sever the ground, Flip the switch. Heck yeah. So with that, I'm guessing that the one with the power coils and the permanent magnets are the ones that are going to counter rotate. The one on the top, I might just totally make stationary. No, I don't know exactly what it's going to do, but or even if it's a good idea to do it, because I know I got to hook them up like in a certain direction. Got to hook the drive coils up in a certain direction too, I'm pretty sure. Like just the way I like to do it is where you started. If you made your own coil, where you started the coil is the start. Where you end the coil is the end. So the energy is always going to come in the start and go out the end. Why would you do it? Why would you even build it any other way than the way that makes sense? Hello, hello. Oh. Okay, so we got primary drive coil, we got secondary drive coil, and we got this coil hooked up to this coil directly. Actually, they're all hooked in series right now. So, but this is small, big, small, and it reduces the power consumption to run at a certain speed. We're 2,000 RPMs. And the amp draw on the rotor and the motor with this style is less. Okay, this is probably dumb. 21.1. We're going to see it. Point 0.1 amps. All right, we'll see how fast the amps go up too. 0.2 amps. 0.3. Hello, hello. 0.4. 0.5. 0.6. 0.7. 0.8. 0.9. 21 watts. 21.1 watts. 1 amp. Fluctuating between 1 and 0.9. 21.1 watts. Mm. All right, we're going to get a tack reading on that now. 2,000. That was weird. All right. Yep. The 2,000 right now is about maybe 2,500 would be the max with the big rotor because everything is vibrating. You want to slow that vibration down a little bit. It doesn't start vibrating till like 2,000 though, so that's good. That's really good. Now it was explained to me that I can double the power of my transistor by linking them parallel. So I'm going to give that a shot. A lower voltage though. Yeah, that's good. The amps are going up faster now. $15. $17.5 or 19.5.9. That's awesome, man. That is just feeling that is like spectacular. That is a oh, how to. No, I'm not sure. This is a how to. It could be. I mean, if you understand a little bit, you could probably get this no problem. Probably look at me and go like, "What's the big deal?" But you got your base, your collector, and your emitter on your transistor. Okay, and you got. This is how we set up the power. The power goes into the collector, and then it goes out the emitter into the coil assembly that you have here, and it goes out of that into the ground. The trigger coil is hooked up here with a resistor on both the front and the back of the trigger coil. So going in and coming out, the energy is resisted. And then it's grounded as well, and then it's connected to the base of the transistor. Now the magnets on this beast are freaking amazing. Neodymium M52s. Powerful. Like, powerful to the point where you don't have to be precise. They're that good. But they are not made for each other. The coils I have out here and the magnets are not made for each other. They're close, but they're different sizes. The coil that's made for the magnet will be the size of the magnet, and the forces will meet up when they're lined up. $2,000. That's actually more than 2,000, but I'm not really counting. So they're these square ones, nice and big, got a nice field. Like I said, you don't have to be as precise with the placement of your coils as you do with the cube magnets. You got to be, your range is significantly less of where you can place things. I think that's awesome. I think this is cool. And when my printer gets here tomorrow, I'm going to, and then throughout the time that I'm spending here, I'm gonna like try and fix what I need is a new cable, because the tool head cable became chafed underneath the clip. I'll even show you. I found the clip popped off, but underneath the clip is a very weak spot in the printer. That's why they made this thing, because yeah, they can't wrap the insulation all the way around. So the very tip where it connects to the tool head is very vulnerable to chafing and other sorts of, bad juju. So what I need is a new cable, and then to try and keep this thing from popping off. But it came pre-assembled, so I don't know how easy that is all going to be to do. But I'm sure I can manage. Just flip it over, take the bottom plate off, remove the cable, insert the new cable. Shouldn't be hard at all, really. I just need to get a hold of the cable. The cable that links the printer to the tool head, which is the printer itself. It's like, it's not the whole thing, but it's like where everything gets done at. Where it manifests is the tool head. So yeah, I don't have too much of anything new. I mean, here is what's going to be on the top. There's going to be those two. Let me get it for you. Now I can either do 6 or 3, but you know, the coils will go in the slots like this. Just like that. So, and then you'll have a drive and you'll have a generator disc with all the coils on it. And it's all going to spin, man. It's all going to be on bearings. It's all going to be able to spin. But this little trigger coil right here will make all this stuff work too. Don't have to use that big one. And I had these 16 gauge drivers hooked up. 16 gauge, right? So I had these hooked up and I had the trigger coil on top of the third one. So there were 3 of the 16 gauge with the trigger coil like that. And it had a lot of like oomph to it. It wasn't going particularly fast because you had such a big air gap, but it was like pow, 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 pow. And it literally sounded like it was awesome. It wasn't just the bearing knocking. It wasn't any, it was just pure energy. And you could hear it. It was awesome. Hello, hello. Bass fishing is awesome. Bass get really, really big, man. Like huge. You gotta be pretty strong to do real bass fishing. You gotta be. Heck yeah. Hello, hello. Okay. So I'm thinking about what else I'm going to do. I'm going to turn all this into a counter rotating. Yo, what's up? Actually, the power's off. So I don't know what's going on there. So cool how like putting a diode in a certain position will totally increase the efficiency of your motor, your coils, everything. And if you put a few of them in the right places, you can just totally make everything work better. So each one of these drive coils is connected in series with a diode, and then the big coil has 3 connections inside of it that are connected with the diode. So it's all connected in series, but it goes 3 strands diode, 3 strands diode, 4 strands next coil diode. So it's pretty neat. You get a lot of oscillation and direct current going through this thing. It's pretty cool. And the only reason I say that is because when you connect a strand to a strand and to another strand without a diode, you get oscillation in that region of your coil. And then when you put the diode, and then anything that goes through, and then that's just the way. Why can't it work that way? It absolutely can. I'm not sure that it does. I do know that the way that I have it set up, everything just goes continuously like this. Well, not continuously, more like one stage of a Fibonacci, and then it grounds. So the end of this cycle is grounding. That's what's happening. I haven't got anything cycling through or regurgitating or recycling even at all right now. It's all just standard connection, power to ground. The only thing that's interesting is I got the two transistors there. Hooked in parallel on the circuit. Yeah, I'm sure that if I put this shaft in the right place in the sidewalk out front, it would crack it, no problem. That's how much vibration's coming off that thing. But it doesn't even start vibrating until like 2,000 RPMs, so I think that's good. Woo, hot. Yes. Oh yeah. That's good. That's good. Where is the Tigger? Tigger-ligger. Tiggs! Come on, baby. Come here, Tiggs. Mm-hmm. This cat is an awesome animal. He plays fetch, and that is so fun. Play fetch with a cat. All right, you can go back in the window if you want. He's like, no, that was good. I want to be picked up. I love my cat. Awesome. It's our cat, but you know, really my cat. I just share it. It's a dog named My Cat, you know? mm. So I'm not really certain. I might do a 26 gauge drive thingy. I have one already done. So this one is already ready to go in at 26 gauge. All twisted up. Oh man, the 3D printing is awesome, man. It's so cool. Once you get on board, you think of all the things you can do with it. You start doing them, but they're fragile. Um, the ones that I'm using right now, I takes. Okay. How are they wound? They're Litz wire, kind of, basically. So I've got a hook in the wall over on one side of my room, and then I got a hook in the wall on the other side. And I go there and back 5 times. Okay, so for this coil right here, there and back 5 times, and then, you know, I cut it. You got 10 strands that are 16 feet long. And then I twisted them. Before I cut it, I twisted them. So they're twisted. They're wound basically the way you would wind a rodent coil wire. And they're all wound counterclockwise. They're hand wound. Absolutely. I couldn't, the wire was so stiff that I couldn't wind it in my winder. It wouldn't adhere. It wouldn't work very well. This one has, I think, 12 there and back at 16 gauge or 26 gauge. I think I'm going to use 26 gauge because I've got 26 gauge. I can make new coils with it. And that little devil spins so fast. Awesome. Yeah, I've been meaning to use some serpentine coils for a motor. I'm not sure exactly. I haven't been able to I need to make a former for that. Yeah, and seriously, I thought a serpentine coil would work very well, but I don't know anymore. I don't know how it works as well as I thought I did. I'm thinking at least for a generator of some kind, but I don't know. I have to make one first and have it work, and then I'll know what it's all about. Mm. I thought these little coils were badass too. Just nice little 4-ounce or quarter-ounce, no, 4-ounce. That's right. Spool. Has some 22 and some 32 on there. That's a nice acute, short magnetic field here. It pounds. You know, and this thing hits hard because of the way it's wound and how small it is. It's a radial design, though. I think you could use it for an axial just by flipping the position, but it works really well with the radial. Gotcha. He's getting so big. Yeah, he was just a little kitten. We found him in the wheel well of a car. Or the people that gave us to him found him in the car wheel. Mm. little bit more. I feel like I want to play with something else right now. So I'm gonna hook this up. Wow, this is kind of difficult to gauge. Nice. That's good. I'm thinking I'm going to try and hook the big rotor up to these coils over here on this rotor, on this shaft. I mean, this is a 6 magnet rotor, and it'll go on these 3,000, in between 2 and 3,000 RPMs. All right, I'm just going to put some more magnets in this. Boop, 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 boop. Oh, man. That's so sweet. And it's cool when you can actually see when that happens. So that's pretty unique, actually. Even to know what to look for. But you're creating a motor with serpentine coils? Yeah, I'm see that's right. I was trying to I just don't know enough about it to make that happen. But I could learn from you. Just one more magnet. All right, let's see. So these are all north facing. Mm. Yeah, those soft iron cores are freaking awesome. Okay, so yeah, it's not gonna work. Got it. All right. Sometimes this stuff is really hard to take apart. Okay. Damn. You can see how that's not going to work. Yeah, no. Huh. I'm going to have to redo. No, I've never had a Hall effect sensor work for me ever. So that is not true. And it's just because they don't want to work for me. I don't know what it is. It's not like I'm hooking it up wrong. Black goes to base, brown goes to power, and blue goes to ground. It's not like I'm hooking it up wrong. Yada, yada, yada. Hmm. Hmm. Come on. Forgot about this part. And I will stand by what I say. Hall effect sensor reed switch isn't going to run this like the trigger coil will. Maybe this one over here I'm working on now. God dang it. I'm not going to be able to do this right now. This is not looking like it's going to be even doable later, actually. We'll see. Well, you can buy me some straps and you can mail them to my address. That'll be awesome. Along with the brackets that I will need to hold all the coils in. P.O. Box, Samsonite Plaza, 0002002. Sucks. God. Just bond, you freaking dumb glue. This isn't going to work. Nope, I don't have any of that crap. No fence links, no nothing. It's just a little piece of metal that's hooked in like a horseshoe shape, but I don't have any of that crap. I don't have it. I don't know. Probably not going to hold. But yeah, that's not going to hold. No, we're doing this. There's nothing else to do right now. There's just nothing else to do. I don't have anything. I've thought about it a lot, and I just don't have anything besides this right now that'll work. I mean, it's a great idea and whatever, but I don't have it. As simple as that. Oh, man. Yeah, I know, right? I think we got it that time. I mean, it is a little bit further out, but I think it's sticking now. All right, number 2. Goodness gracious, man. No. Oh. God, stop moving, god dang it. Yeah, I gotta keep moving stuff to the storage unit. Make room for different, new, better things. Oh man. Yeah, they could be nice if I had some. I can buy some, but they're not going to be here for like 2 days. But yes, zip ties sound, well, we could try and make something like that work, but I mean, honestly, glue is probably more precise with the way the holes are in the table. But I don't know. Definitely be worth a shot because I'm really sick of glue. I just use it because it's not efficient, but you get a lot more freedom. I know that sounds weird, doesn't it? But these holes are not, there's no center hole in this board. There's no center hole. And that's how the holes are. And I don't really like it that way, but then we'll hook these up in series and see what we can get out of it. These they're different style coils. I mean, it's like all core. There's barely any wire on these cores. All right, we'll just sit on this for a while. A minute here. Yeah, zip ties. I had a bunch of zip ties at one point, like way back in the beginning. I have no idea where they went. But I got to get big ones, that's for sure. Hmm. You know what? I hope this works, like right off the bat, because that'll be good for me. There is a, based on previous attempts at stuff, 65% chance that it won't work. But we'll see. Come on, dude. This is not even fun anymore. Let's just get in the hole. You too good for your home? You too good for your home? Here we go. What's up, Wonder? Yeah, I think my kid gets scared when I'm hell bent on getting something done. All right. All right. So power, base, coil, and now we got to connect all of those ones and then ground it, and we should be good. Now, should I put a diode in between each one of these? Yeah, that sucks. Mm. Mm. We got it. All right. Ground this beast and we'll give it a whirl. All right. Okay, they're probably hooked up the wrong way. Because it wanted to go at first. See, it wants to move, but I think after this one, we got to switch some stuff around. It might be the diodes, because there's not enough going on in between them. But God, Jesus, this sucks so bad. All right. Well, I'm running out of wind here. I'll need 3 more what? 3 more what, bro? Yeah. I don't need 3 more coils to make this work. I do not. Let me think here. I just need to make this longer, and I can't do it right now. not long enough. It wasn't designed to use this rotor. It was designed to use this one, and therefore none of the connections are long enough. That's what's going on right now. Okay? Nothing else. Nothing more, nothing less. And I don't want to. So this one is off. This one is off. I could use those. But it's just ridiculous how long it's going to be now. So you've never actually hooked up a coil the wrong way to a coil before? So basically, when you spin it, nothing happens because they're canceling each other out. And it's all really based off of the first coil, the coil the power goes into. You have to base everything off of that coil, nothing else. Take care. All right, so I'm going to get this connected and we're going to give it like one more shot. And then I am going to call it for the day. And I'm working on a lot of stuff. I need to get a lot of stuff done. Right there. Plug this one in. Now I just got greedy. One more. And there's one last thing I'm going to do, and that's use a reed switch. It just doesn't catch. Somebody has got something and they're trying. I hear fire, police officers, and EMS. So it's like, it's a windy day. Somebody's trying to burn down the neighborhood. Yeah, that's not good. Oh man, that sounds absolutely bad, right? What I'm listening to. All right. Just gonna plug this. Mm. All right, let's. Yeah, they're definitely fighting each other. I'll have to mark them. They're not marked. That's what the problem is. So the start, something's not aligned right because that's just whatever. And whatever that guy said was not what's going on here. This is not lined up right. When you got one end going into another end, you will cancel the coil out. Here we go. Getting some motion here. That's good. But it looks like just motion from one coil, like I was saying. They're not lined up correctly. So two are canceling each other out, and one is doing all the work. Because I know this goes really fast. This is nothing. But yeah, I'll get it sorted out before the next time, for sure. All right. So it works. Doesn't work very well. I'll get it all fixed up for the next time. All right. Well, thank you very much. I really appreciate you guys checking all the stuff out, working it out with me. No, I'm not. This one, I was just trying to upgrade it from this rotor to this rotor. It's not really an upgrade, really. I think the smaller rotor is way better. And no, all the stuff that I'm doing right here, I can pretty much touch the wire and I'll live. So as long as we're in with that kind of scope, that's good. That's where we're at. Fusion power, we're not doing that. I'd love to get into plasma though. That would be really, really cool. So like transformer, 12 volts to 65,000 volts, that kind of thing. Get some nice arcs going. You know, some color up in here. Okay, so I don't know. I think we're all good. There's a lot of things I want to do. There's absolutely nothing in this genre that I need to do. Just a lot of stuff that I'd like to try out. So please, while addressing or dropping a comment, suggestion, please don't use the word you need, because I don't need any of this. I really don't. Please be kind. Thank you very much. Bye now.